common emitter circuit configuration. Common emitter circuit configuration. Right, please write the heading like this. Under this, please write, in this circuit configuration, emitter is common for both input and output. In this configuration, emitter is common for both input and output. Right. So let me draw a transistor like this. Please tell me whether this is a PNP transistor or a NPN transistor. PNP or NPN?
NPN, sir.
Speak loudly.
NPN, sir.
Reason?
The arrow is away from the base.
Arrow is away from the transistor. As the arrow is away from the transistor, this is an NPN transistor. Right? This is collector. It's common for both input and output. Got it? Then if emitter current, arrowhead is away from the transistor, it means emitter current flows away from the transistor. If emitter flows away, base current flow in, collector current flow in. What has happened to my screen? It's not. Is it okay now? Yeah. If emitter current flows away, the other two currents flow in. Flow away, flow in. If emitter flow away, other two flow in. So to send a current, look at what here. This IC current should start from here. To send a current into this direction, the positive terminal of a battery should be like this. Then only IC current can flow into the transistor. So negative terminal should be connected like this. Similarly, IV current flow in. To send a current into this direction, positive terminal of a battery should be connected like this. So that's how we connect the batteries. Draw the circuit. Right, so we can do the same circuit for PNP transistor. Look at board. What is this transistor? PNP or NPN? Lamai?
PNP, sir.
How do you identify it?
Arrow is towards the base.
Arrow is towards. Arrow is towards. Therefore, this is the PNP transistor. Arrow towards mean the current. IE current flow into the transistor. If IE flow in, IB, IC flow away. IE flow in, IB, IC flow away. Right? So, if I draw the battery, this IC current flows like this, IC flows like this. A current can enter through the negative terminal. Current can enter to a battery through the negative terminal, normal situation, under normal conditions. So therefore, this should be the negative terminal. It should be positive terminal. Can you understand? That's how we determine the battery connections here. And emitter is common for both input and output. Similarly, IB current flows like this. IB flows like this. Again, a current can enter, current normally enters to the negative terminal. So this should be negative terminal. Negative, positive. Now both this IB current flow through the battery and reach to this point. IC current flows through the battery and reach to this point. IB, IC connected together and flow into the battery as IE. Right? Draw both circuits here. Who wants more time to draw the circuits there? Lamai? Who wants more time? Please raise your hand up in Zoom chat if you want any more time to draw the figure.
Sir, can you kind of name the terminals, because it's a kind of like really confusing.
Sorry, I didn't hear you.
Can you kind of name the terminals, because it's a kind of confusing.
Yes. Why not? Definitely. The terminal with an arrowhead. The terminal with an arrowhead. Always. For both NPN and PNP transistors, the terminal with an arrowhead. The terminal with an arrowhead is always emitter. The terminal with an arrowhead is always emitter. Right? The other hand, hand with the arrowhead emitter. The other hand is collector. So this should be collector. This is collector. This is also collector. Right? So this one is base. This is base. Very good. A very good request, and it is very useful for all the students. Very good. Name the terminals. This spelling wrong. Collector, TOR. Collector. Emitter, correct. Please correct the spelling mistakes. Please. Collector, TOR. Emitter, TER. Base is base. Can somebody read the sentence? I have given one or two sentences below the subheading common emitter subheading. I have given one or two sentences. Somebody please read the sentences I have given under this common emitter subheading here. Somebody in the class.
In this circuit configuration, emitter is common for both input and output.
Thank you, dear. Thank you very much. In this circuit configuration, emitter is common for both input and output. In this circuit configuration, emitter is common for both input and output. Thank you, dear. Right. Now I'm going to go to a very important subheading. Very important subheading. Look at both. Common emitter. Common emitter. Common emitter. How can I write the space? Common emitter amplifier. Can you see this? Can you see the heading? Common emitter amplifier, right? Configuration can be used to construct an amplifier. Configuration. Common emitter circuit configuration can be used to construct. Common emitter circuit configuration can be used to construct. Can be used to construct an amplifier. Common emitter circuit configuration can be used to construct an amplifier. An amplifier. Full stop. There are three main reasons. There are three main reasons. There are three main reasons to use common emitter configuration. There are three main reasons to use common emitter configuration. To use common emitter configuration In amplifier circuits, there are three main reasons to use common emitter configuration in amplifier circuits. In amplifier circuits, common emitter configuration in amplifier circuits. Number one, common emitter configuration has the maximum voltage gain. I'll explain all these things, don't worry. Common emitter configuration has the maximum voltage gain. Number one, common emitter configuration has the maximum gain. Number two, it has the common emitter configuration has the maximum voltage gain. Number two, it has the maximum current gain. It has the maximum current gain. So current gain is maximum in common emitter amplifier circuit, common emitter configuration. I'll show you, I'll explain what the voltage gain is, I'll explain what the current gain is, you just write them now. 3, it has the highest power gain. It has the highest power. It has the highest power. Don't use the term gain, say it has the highest power. Right. Somebody read those point and the 3 points here. Please, somebody please unmute the mic and read that note quick.
Common emitter circuit configuration can be used to construct an amplifier. There are 3 main reasons to use common emitter configurations in amplifier circuits. First one, common emitter has the maximum voltage gain. Second one has the maximum current gain. Third one has the highest power.
Thank you, Ria. Thank you very much. Now I'll draw the circuit diagram. I'll draw the circuit diagram. Look at board here. Right. So we use common emitter configuration, and normally we use NPN transistor. Can you tell me the reason for us to use NPN transistor in amplifier circuits here? What is the reason for us to use NPN transistors in amplifier circuits? Last week I have given the reason. Think. Why? Why do we? Yes, dear.
It is the fastest switching circuit.
Because NPN transistors are fast-acting transistors. NPN transistors have the fast-acting ability. Because majority charge carriers, majority current carriers in NPN transistors are free electrons. Majority current carriers are free electrons. So electrons are fast moving. Therefore, NPN transistors are fast acting transistors. Therefore, we use NPN transistors in amplifier circuits as well as switching circuits. You read the theory note that I have given under NPN transistors. I have clearly explained that point. Right, now look at board. Let me explain how to construct this amplifier circuit. Right. So first thing is we should draw the common line. First thing is we should draw the common line. Then we should connect it to the ground. Should connect it to the ground. Right. Then we connect a resistor to the emitter. The resistor which is connected to the emitter is said to be RE resistance, RE ohms. RE ohms. Connect to the ground means you connect a wire to this and connect the other end of the wire to the earth, which is known as ground. I'll explain everything, just listen to me. Emitter current flow through this resistor. Emitter current flow through this resistor. If a current flows through a resistor to a one direction, the resistor generates a voltage into the other direction. Whose law is that? Lamai? If a current flows through a
Lenz's law.
resistor into one direction, the resistor generates a voltage into the other direction. Whose law is that?
Lenz's law.
Eh?
Lenz.
No. Whose law is this? Whose law is this? Eh?
Ohm's law.
Ohm's law. So, if this point, collector point is normally named as C. Sorry, this is emitter. Therefore, this point is normally marked as point E. Not easy. This is E. This is point E. And we normally mark this point as D. Then potential difference between D and E can be found. What's the law that should be used to find the potential difference between D and E? What is the law? What's the equation that can be used to find the potential difference between D and E? Lamai?
Ohm's law.
Ohm's law.
V equal IR.
V equals IR. V ED equals IE into RE. Whose law is this, dear? Lamai?
Ohm's law.
Ohm's law. Right. Then we connect a resistor to this point. This is said to be collector. Collector point is normally indicated by the letter C. C E. Let's say this is F. Sorry, C E F. That's better. Ne? C G. C E F. Right. And now V E F. This is RC resistor. IC current should be provided by a battery. This battery voltage is said to be VCC volt. This point is normally denoted as D. This is point D, capital D. IC current flows like this. Don't draw the circuit. Don't draw it. IC. This is IC. This current starts from the positive terminal of the battery. IC current starts from the VCC battery, positive terminal of VCC battery. IC flows like this. Good. So, if a current flows to a resistor to a one direction, that resistor generates a voltage into the opposite direction. So, if a current flows to this direction, there will be a voltage into the opposite direction. Right? Normally, we indicate this voltage as VDC. How do we find VDC voltage, dear Lamai? How do we find this VDC voltage?
Law, sir. Ohm's law.
Speak loudly.
Ohm's law, sir.
Ohm's law. So again, I can write V equals IR. Therefore, potential difference between the points D and C. Potential difference between the points D and C is VDC equals IC into RC. Whose law is this, dear? Lamai, whose law is this?
Slow, sir.
Ohm's law, right? Ekat hari. And this voltage is potential difference between E and F. VE F. What about this voltage then? I'll erase this collector name here because then it will be it is very difficult to draw the things, right? Then what about this voltage here? This is point C, this is point E. And this voltage V, this is E. This is the voltage at C, this is the voltage at E. So this voltage should be
E.
VCE. Right. Then base. Base is connected like this. A special method is used to connect the base to the circuit. Still I didn't draw the mic. Still I didn't draw the speaker. An amplifier is used to get a louder sound. An amplifier is used to get a louder sound. We connect a mic and a speaker to an amplifier. Still I didn't connect the mic. I didn't connect the speaker. That's why I asked you not to draw it. So we use two resistors to connect the base like this. I'll explain the use of these two resistors. This is R1, this is R2. Right. Then actually this is not only IC. Because of R1, this R1 takes a current of I1. This R1 takes a current of I1. Therefore, this is not IC, this is IS, supply current. IS. When the supply current reaches the point D, it divides into two sections. When the supply current reaches to the point D, it divides into two sections. What are the two sections, dear? Look at board and tell me.
I1 and IC, sir.
I1 and IC. Similarly, when I1 current reaches to this point, let's say this is the point B. When I1 reaches to the point B, it divides into two sections as, look at board carefully, it divides into two sections as IB and I2. I2 current flows through this resistor and I2 current reach to the point F like this. And all the things, IE reach to this point, IE plus I2 is IS. I can prove all these things. And this IS current flows back to the positive terminal of the battery. Now circuit is completed. The only missing thing is the battery and the speed. The only missing thing is things are the mic and the speaker. What are the missing things there? Mic and the speaker. Speaker is connected like this. Look at board. Speaker is connected to the point C and the ground. Like this. So I do not draw the speaker. I just say this is the output voltage, V out. Normally we connect a capacitor like this. So C2 is the capacitors. We connect the transistor to the speaker. Actually, there is a speaker here. I didn't draw it. Through a capacitor. Similarly, can you see the board? Yeah. Similarly, we connect a capacitor here. We connect a capacitor here. Before we connect the mic. Mic is connected to these 2 points. V in. That's how the things are connected. This is C1 capacitor. This is the complete common emitter amplifier. We use an NPN transistor for this. So I'll erase the unwanted things. Draw the circuit in the biggest possible size. Draw this circuit in the biggest possible size. Start. Okay, please draw this figure. There are many equations to be written with this figure, this diagram, and this is what you get in the exam, right? Normally, they will ask you to draw the 6 diagrams that we have already drawn, and the questions are given from this circuit diagram. So this is more important than all the 6 diagrams that we have drawn so far. So I'll explain the equations. I'll give you all the equations and I'll explain this further next week. I think that's enough for today. Take care. Good night. You must draw this circuit before you leave the class. Okay. Good night. Take care. Bye.